Alrighty, so today we're going to be looking at quartiles and interquartile range. So what does it mean by quartiles? Well, quarter means kind of like a quarter. So you imagine you have a block, and this block is going to represent all of our data. And the first thing we want to do is we want to split the data in half. We can do that by calculating the median, because the median is the middle of the data. So once we know what the median is, we can split our data set into a lower half and an upper half. But the point of a quartile is we're not looking for half-iles, we're looking for quartiles. So we're looking for quarters. So we need to make two more cuts. We need to make a cut down here and a cut up here. And since we're just making cuts that are in the middle, well, we're just going to do median calculations. So Q1 is the median of the lower half, and Q3 is the median of the upper half. Now you'll notice there's actually 5 lines here, and so the first and the last one, well, that's just going to be your smallest number, your minimum, and your largest number, your maximum. We call these 5 numbers the 5-number summary, but today we're going to focus on the middle ones. So the range itself is the distance between the minimum and the maximum. So to calculate it, you just take the minimum away from the maximum. But that tells us the spread of the entire data. It does not tell us the spread of the middle half, right? Because you could imagine this right here, that is the lower half. This over here would be the upper half. But this in the middle here, that's the middle half. And that's a really interesting thing, because what it says, this is the 50%, the middle two quarters, who are close to the median. So how did the average go, and how consistent were they? And that's what the interquartile range can tell us. So the interquartile range, or IQR, is the difference between Q3 and Q1. All right, so now we're going to have a look at some actual numerical examples and have a crack at calculating both the range, the interquartile range. Alrighty, so this is our data set. In this case, we've got 9 numbers. Now, the first time whenever we're doing anything to do with medians or anything like that, always good to put your data in order. And you can see 6 to 13, the data is in order. Alrighty, so first of all, let's find our median. Now, since n equals 9, because there are 9 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, then the median is going to live in the n plus 1 over 2th position, 9 plus 1 on 2, which is 10 on 2, which is 5. So it's in the 5th position. It's not 5, because 5 is not even in this data set. So 1, 2, 3, 4, 5, and our median is 10. Now we have split our data into a lower half and an upper half, and now we need to work out the medians of each of those. So Q1, the lower median, it's going to be found. Well, how many data is in the lower half? Well, there's only 4, because 10, because it's the median, it's like the divider. It doesn't actually get to count. So 10's not in the lower half. So there's only 4 numbers. So n equals 4. And so then we get n plus 1 over 2. 4 plus 1 over 2 is 2.5. So it's in the 2.5th position, 1, 2, and 3. So it's in between 7 and 8. So Q1 is going to be equal to 7 plus 8 over 2, which is 7.5. For Q3, on the other hand, well, n is also equal to 4. There's only 4 numbers. So since n equals 4, n plus 1 over 2 is also going to be equal to 2.5. It's also going to be in the 2.5th position. But it's not going to be down here. It's actually going to be 2.5 position above the 5th position. All right. So if we want to count from just here, it's the 1, 2, and then a half. So in between these two. But counting from the beginning, it's actually the 1, 2, 3, 4, 5th, 6th, 7th, and 8th. It's actually in between the 7th and the 8th spot is where the median would be. That's going to be important for later, but for the moment, we're not going to worry about that too much. But just an important point. So it's between 12 and 13, so Q3 would be equal to 12 plus 13 over 2, 12.5. And now I figured out my 3 hard numbers. The easy ones are the min and the max. the smallest number and the largest number, and so I can work out my range in interquartile range. Since the largest number is 13 and the smallest number is 6, 13 take 6 is 7, so the range is 7. Our interquartile range, on the other hand, is Q3 minus Q1, which is going to be 12.5 minus 7.5, and that's equal to 5. So that is how you can calculate your minimum, maximum, Q1, Q3, and median, and then your range and interquartile range. Sometimes we call the median Q2 just because it's in between the Q1 and Q3. Let's do a different data set just to check we're all good. Alrighty, so let's look at this data set. Now, first of all, you'll notice it's not in order. Step 1, put it in order. 2, 3, no 4s, 5, 6, 7, 8, 9, 10, 11. Now there was originally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alrighty, so we have counted up all of our numbers, and we can see we've got all of the data there. So, split our data in half. Let's find the median. So the median, since there's n equals 10, there's 10 numbers. N plus 1 over 2 is 10 plus 1 over 2, which is 5.5th position. 1, 2, 3, 4, 5. So it's in between 6 and 7, so the median equals 6 plus 7 over 2 equals 6.5. So what do we do with 6 and 7? Well, the median's job is to split the data into a lower and upper half. So there's two choices. Option 1, I cancel both numbers, and then I'm left with 4 in the lower and 4 in the upper. But neither 6 nor 7 are actually our median. The median's in between them. So instead, we split the data in half here. So we've got our lower half and our upper half, including the 6 for the lower half. Alrighty, so let's work out our Q1 and our Q3. So for Q1, n is equal to 5, as is the same for Q3. And we get n plus 1 over 2, 5 plus 1 over 2, 6 over 2 is 3. So it's in the third position, which is 1, 2, 3, 3. So Q1 is 3. And then similarly for Q3, it's also going to be in the third position because n also equals 5. So it's going to be in the third position. And the third position is 1, 2, 3. But notice that it's actually, if you count from the beginning, 1, 2, 3, 4, 5, 6, 7, 8. It's actually in the 8th. Yeah, it's actually in the 8th position. Which makes sense because when we think about it, and this is probably the hardest part, is that this is kind of in the 5th position, and this is 3 positions after that. 3 positions after the 5th position, well, that would be the 8th position. So when counting from the start, it would be the 8th position, but when counting from just the upper half, it's just the 9th position. Now, the 3rd position. So just be mindful of this, because we're going to be needing this later. So in this case, Q3 is just equal to 9. But when we're doing frequency tables, much easier if you can work out its position relative to the beginning, not to the second half. Alrighty, but anyway, that's a later problem. Range, max take min. What was the max and min? Well, I remember the min was 2, but what was the max? 11? Yeah, so 11 take 2 is 9. And for the IQR, it's going to be Q3 take Q1. 9 take 3 is 6. And generally speaking, your range should always be a little bit bigger than your IQR, sometimes a lot bigger, sometimes not as much. It just depends on the data set itself. Alrighty, so there we go. See you in the next one. Goodbye.